Good morning, everybody. This is a live severe weather briefing as the threat of tornadoes and a severe weather event is increasing on Wednesday. Looks like Wednesday target area is going to be from eastern Louisiana, central southern Mississippi, into western southwestern Alabama area. And that threat is definitely trending up. It does appear that the European model and the NAM model trending with a bit of a stronger system certainly was onto something. And there you can see the upper level pattern. This is the forecast for Wednesday evening. And look at that stronger lead wave. This is that lead trough axis. It even has a little bit of a subtle negative tilt. And we don't want to be too hung up on the tilt of these systems as they're coming in. You can also see the system dropping down through California, helping to bring some big time snows to the mountains out there, the Sierra Nevadas and the Pacific Northwest. This system is going to cut off down here, down off Baja or Southern California, and that's just going to be waiting out there like that kickball as we've been talking about. And then another system is going to dive south through the Pacific Northwest, and it's just going to launch that kickball northeast across the central and southern U.S. That's going to be the New Year's Day system. But we first want to target Wednesday, as we are experiencing a much stronger lead wave here. We'll call this the trailing wave because there's another wave that ejects up toward the southern Great Lakes on December 28. But it's this trailing system, basically a gyre just spinning over the Canadian prairies with these systems in a very active jet stream along its southern periphery. But we're not getting any Arctic intrusions just yet, and that's why we have this reservoir of 70s dew points just sitting in the Gulf of Mexico. And actually this lead system helps to tug that moisture up from the Caribbean up into the western Gulf of Mexico so that this trailing system can come in here and be just enough lift in the atmosphere to trigger some storms to develop down here within that instability across eastern Louisiana into central and southern Mississippi and eventually into Alabama. And you can see this ribbon of flow here down along the southern periphery. That's really the key for this severe weather event on Wednesday, because the main wave is lifting up to the north through Missouri. That's going to trigger a main low-level jet tucked right up against that vortex across eastern Missouri into Illinois. But there's another subtle low-level jet maximum that develops off to the south across the mid-south, and that's in association with this cyclonic curvature with that southern ribbon of flow, and also an extension of that cyclonic curvature from the lead wave there, basically acting in tandem. But it does look like severe weather on Wednesday, December 29, certainly is increasing. Here is the low-level jet. So notice how you kind of get two different low-level jets, the main axis up there across Missouri and Illinois. But look at that ribbon of increasing flow across Mississippi and Alabama. And you may remember from our outbreak a couple of days ago, that low-level jet was basically 20-25 knots or less. But we did have a very favorable shape to that hodograph, and so just the increasing magnitude of that low-level jet across eastern Louisiana, Mississippi, into Alabama is creating much more favorable hodographs and wind shear for tornadoes down in the Mid-South. And so let's dig a little bit deeper on the NAM model. It's been in agreement with the European model on this stronger system. And there you can see that low-level jet zoomed in a little bit closer. Notice how it's up to about 40 knots there. 40 knot southwesterly low-level jet on Wednesday evening, if we get storms, is going to be create the potential for even a strong tornado threat. And now we can look at the 0 to 1 kilometer EHIs. That basically shows you where that surface-based instability co-locates with the 0 to 1 kilometer storm relative shear. And you can see that bullseye right over the Jackson area, Jackson, Mississippi. That I-20 corridor certainly looks in play. And even down toward the New Orleans area, southeastern Louisiana, certainly some very favorable soundings with that low-level jet, southwesterly low-level jet increasing to about 40 knots. And we can click on a forecast sounding here for the NAM. And that is a very favorable forecast sounding in terms of thermodynamics and your hodograph shape. And I think when you actually have a low-level jet up near 40 knots, look at how that shape is even more favorable. And your 0 to 1 kilometer shear is in excess of 200 with this hodograph. You can see quite a bit of directional shear as well. And with a 40 knot low-level jet, that shear vector is even longer, and you still have that near-due easterly storm motion at about 40 knots with that stronger upper-level flow. And basically that area contained within that curved hodograph and that storm motion vector contributing to some substantial 0 to 1 kilometer shear. The thermodynamics are even more favorable. Look at this elevated mix layer, dry air coming in the mid-levels. That's helping to steepen those lapse rates, or the rate at which that red line decreases temperature with height. And the difference between that dashed line and the red line contributes to CAPE, or instability. So imagine a hot air balloon rising up along the dashed line with that temperature. As long as it's warmer than the red line and above that red line, it's going to keep on rising all the way up until it reaches the equilibrium level up on the top of the troposphere. That usually represents the top of the storms. Sometimes if those updrafts are substantial enough, then overshooting tops will poke in above the tropopause into the stratosphere. And look at this capping inversion down in the low levels. Will that capping inversion be strong enough to prevent storms from initiating during daytime? Or will they initiate right at sunset? Will there be no storms at all? That's really the limiting factor with this event, are the number of storms. But even the regular NAM is showing the initiation of these prefrontal confluence lines, renegade storms, even from southeastern Louisiana up through the Columbus area to the west of Tuscaloosa. And those storms are going to track into western Alabama with time. Very favorable soundings for that tornado threat. Very moist as well. Look at the mid to upper 60s dew points reaching all the way up well north of the I-20 corridor, even up toward northern Mississippi. Look at that reservoir of those 70s dew points just sitting down there over the open Gulf of Mexico. That's a big problem, and that's why we're code red right now with a bright red coloring, just because it looks like we're going to have two chances for tornado potential, one on Wednesday evening and overnight from eastern Louisiana, southern Louisiana, across central and southern Mississippi, central and southern Alabama, as well as you're going through the evening hours. Notice how that moisture begins to invade Alabama as well during the overnight hours, and I think that tornado threat likely is going to move into western Alabama, central southern Alabama with time. And then the moisture just sits back there in the Gulf of Mexico getting ready for New Year's Day on January 1st, where it looks like an even bigger wave potentially is going to come through. So it looks like storms will initiate at around 6 p.m. and likely will continue during the overnight hours. Look at the significant tornado parameter. And this can show you basically where those storms could fire. And they could develop a little bit earlier in the afternoon as well, even about 4 or 5 p.m. back here down toward the lower Mississippi River Valley, southeastern Louisiana. Basically a supercell factory out there with those prefrontal confluence lines developing. Southeastern Louisiana into southern Mississippi. This is that STP. Notice how it rockets northward with time, all the way up to that Highway 62 corridor, a little bit further north than Interstate 20. Interstate 20 is right within the heart of that stronger significant tornado parameter. And look at it lift off to the northeast and move in to western Alabama as well. So that definitely expands as you go toward about 9 or 10 p.m. toward the later evening. And as you get closer to midnight, even starting to see some yellows begin to appear up toward Tuscaloosa, Columbus up to Tuscaloosa as well. That significant tornado parameter lifting up northward toward the Tupelo area, even northwestern Alabama, even central and eastern Tennessee could get in on the action there a little bit later toward midnight. And it continues into the early morning hours on Thursday, the day before New Year's Eve. So it looks like I'm going to have to activate storm chase mode. I did have tickets to the Alamo Bowl. I was going to meet up with a bunch of my friends from the University of Oklahoma days back when I was going to college. We had an Airbnb. We're going to go support the Sooners during this time with a coaching change with Brent Venables in there. But it looks like I'm going to have to be storm chasing on the night of the 29th. So I'm going to have to contact my friends and let them know that, unfortunately, I can't ever make plans for leisure. Winter, spring, summer, doesn't matter. Fall, always storm chase mode. And for me, in my life, storm chase mode always takes priority over everything else, and it definitely will during the rest of my life, as well as I storm chase with another 40 to 50 years with medical advancements. But it looks like I'm going to have to chase on the night of the 29th Each NAM model is trending more bullish with time, and the 12Z runs are coming in right now. I'm definitely interested in seeing the 12Z runs. This is the morning of the 29th with that low-level jet pumping that moisture northward. You can see the upper 60s dew points pumping northward to the I-20 corridor. Rocket fuel for tornadoes just sitting down there over the open Gulf of Mexico. And the fact that that moisture does not get cleaned out by this system is going to set the stage for an even bigger trough ejection to happen right behind it. So let's take a look really quick. We'll go back to the 6Z runs as these models are coming in. And it does look like between 6Z and 12Z, the NAM model is trending even more moist down across southern Louisiana, southern Mississippi, the morning of Wednesday, the 29th, which means that it's probably trending even stronger with that system. So let's quickly take a look at the January 1st system as we're waiting for those 12Z models to come out, which on my initial glance just looks like a stronger wave, simply because there's greater moisture now. You basically can look run to run on these models and start to notice some trends. You could start to see other models trending toward the other models as well. We've seen the GFS model trend toward the European and the NAM models with this lead system, which is hinting that it's going to be more substantial. And definitely don't want to sleep on the 29th system, focusing too much on the January 1st system. But look at how moist that is on the 29th. That's a very large warm sector. Storm Prediction Center, Evan Bentley there, great meteorologist, has been on this for days with that day 4 and 5 outlook for this event on the 29th. He was definitely looking at the European model with that stronger lead wave, and that ended up being correct in that mid-range. And now let's take a look, though, at the GFS model, and then we'll compare it with the European model for that next system. But here's the 29th system. A lot more cyclonic curvature in the upper levels on this 6Z GFS. Definitely a more substantial system. And you also have this stronger ribbon of flow displaced a little bit to the southeast of the main wave. And then you got this other one diving south down off of California. That's going to be that closed upper low. See how it's closing off, trying to close off at least off of Southern California. And then you've got this lead parent system, we'll call it, diving south across the Pacific Northwest. That's going to be the system that is going to pick up the kicker system on January 1st, and that's that tandem trough ejection that we've been worried about. That's that same tandem trough ejection that happened on December 10 and 11. And you don't want to anticipate a repeat ever just because there are similarities in the trough ejection shape. You've got this parent trough that's diving southward through the Pacific, through the Mountain West. You've got this closed low that was off of Southern California and Baja that's ejecting to the east of that trough. This trough is slow enough to where it's picking up this lead wave. We'll call this a tandem trough ejection leading in to New Year's Day. And it is a little bit slower, the parent trough. It is stronger even compared to the parent trough of December 10 and 11. But that lead wave basically surges downstream of that main wave over multiple states, and that leads to a monster low-level jet downstream. The timing doesn't look as favorable in the 6Z run, at least, for that severe weather. That's at 0Z. It does look more favorable for a daytime potential. But look at the 850 low way up across the Great Lakes, and you have this massive low-level jet here over multiple states. The entire Mississippi River Valley, Ohio River Valley. You've got these ribbons of stronger low-level flow all the way down through the Mid-South. So that, to me, looks like it's still going to be a pretty substantial event. But there are some differences in the European model and the GFS that will need to iron themselves out. That's the 30th. And this is the European model. So you can see the European model has an even deeper, more consolidated trough ejection, and look at that low-level jet. Stronger over multiple states. It is a little bit further south. This is last night's European model. And there still are some subtle differences in the trough shape. Look at that European model. That main wave. 543 contour back there, diving south, just east of the southeast of the Four Corners. Here's your lead wave, a bit of a embedded trough axis here. The models are having trouble at how well that closed low is going to maintain its identity, similar to the December 10 and 11 event. But that is a nasty shape right there, as depicted by last night's European model. And the parent trough hangs back, and you get a lot of flow downstream there, getting pinched between that ridge over the eastern Gulf of Mexico and the southeastern U.S. And there it is. There's that low-level jet axis that marches to the east through central and eastern Kentucky, central and eastern Tennessee, back through Alabama, central and eastern Mississippi as well. And then the low-level jet starts to ramp up, setting the stage for a potential event just east of the Appalachians as well on January 2nd, with a squall line moving through. The European model definitely shows a southeastern threat, a little bit more substantial than the GFS, with a deeper parent system. But then look at that low-level jet, 80 knots out there, just to the east of the Appalachians. Squeeze play between this high off of the southeastern U.S. and that trough across the eastern United States. And this could usher in a pattern shift that could finally bring some winter weather down for the central and eastern U.S. We're getting record-breaking warmth across the Mid-South and the southeastern U.S. I'm going to be readying the Gravitron network once again. I got to start charging those today. That's our science mission that is powered by Flex Seal. And we're going to be bringing that out there and deploying that network of gravity wave sensors, basically high-resolution pressure sensors in the path of these tornadoes. If I can get more deployed, like 3 or 4 of those deployed out ahead of the tornado, then we'll be more likely to have a direct hit. We did deploy those Gravitron sensors a little bit early on that supercell, just before the Monette wedge touched down in northeastern Arkansas. But we did sample some incredible gravity wave action, especially with the derecho event up into northeastern Nebraska into western Iowa, with over 50 tornadoes reported during that record-breaking December. But it looks like that record-breaking December is going to continue with the December 29 event, and I wouldn't be surprised to see a lower-end outbreak of tornadoes. An outbreak of tornadoes would be at least a half a dozen tornadoes over the same region, and I certainly could see half a dozen tornadoes on this event Wednesday night, December 29, helping to continue that record-breaking December that we've seen so far. And then we're going to get the January 1st event. That's the New Year's Day ejection right here. This trough, this is the parent trough, and then the lead wave basically carves out a much larger. And I think that the models are going to hone in on the details with that trough ejection as we get a lot closer to the event. I'm also interested in breaking down the HRRR model, the convective allowing models that will depict December 29's, just how widespread that convection is going to be. And I wouldn't be surprised if the Storm Prediction Center upgrades to an enhanced risk. They certainly did mention the potential for that upgrade to an enhanced. Right now, there is a slight risk by the Storm Prediction Center. There you can see that slight risk across multiple states, northeastern Louisiana, also across central northern Mississippi. And that slight risk does include southeastern Tennessee as well. And as we saw in those models, near midnight into the early morning hours on the 30th, that surface-based instability and wind shear ejects off to the northeast, even reaching up into eastern Kentucky with time. So that's your risk area, and it does mention the potential upgrade to an enhanced risk with time. We also do have a new risk area out for January 1st as well. That's going to be your day 6 outlook, and that includes those similar areas from eastern Arkansas, northern Louisiana, central northern Mississippi, northern Alabama, large swath of Tennessee. Basically, the whole entire state of Tennessee needs to keep an eye on this trough ejection on January 1st, moving into southern Kentucky as well, including that Bowling Green area. So let's take a look and see how far these 12Z models have progressed as well. Let's see if we could look at the 12Z models for the NAM and see if it even has that stronger lead wave. This is on Wednesday, 21Z. Look at that warmth across the southern U.S. This is in the afternoon, 3 p.m. So you can see those temperatures rising up through the upper 70s down across the southern U.S. That warmth always comes with a price. You've got dew points just cooking down here in the Gulf of Mexico, getting pulled northward by these waves out of the Caribbean as well. And that just sets the stage for big problems. Look at that moisture just sitting down here, mid-upper 70s in the Gulf of Mexico. This is like April and May type moisture in the Gulf of Mexico, and it is during late December into January. And look at that, an even stronger, slightly slower wave. Look at this jet streak. And it looks like this ribbon is even stronger off to the southeast of it. More importantly, let's look at the low-level jet. And this is at 21Z. It looks like they're more connected now as well. You have that main 850 low over southeastern Nebraska. And now it looks like that low-level jet is a lot more connected in the new NAM. So the latest NAM is trending toward an enhanced risk, if you ask me. And now we got the forecast out to 0Z. Notice how it is a little bit more connected, this low-level jet. And so even though you don't have any of those 40-knot barbs down there across central southern Mississippi, I do think that it is a stronger wave, and that's leading to greater 0 to 1 kilometer EHIs down there by 0Z. So the NAM is definitely trending toward a stronger system on the 29th of December. Look at those yellows for your 0 to 1 kilometer EHI. You don't want to get too hung up on these composite indices unless you understand what's coming together to create the composite, and that's surface-based Cape. Look at that Cape bomb off of the western Gulf of Mexico. That's Cape in excess of 3,000, that big reservoir of Cape. That's the rocket fuel for these tornado outbreaks. And look at that Cape then invade southeastern Louisiana up into the I-20 corridor, central southern Mississippi. Definitely the threat of renegades out there. Let's take a look and see the regular NAM. Still has the threat of some renegades lining up in these prefrontal confluence bands. One closer to the Mississippi River Valley, one out ahead of that as well, out toward Hattiesburg to Columbus, eventually moving up toward the Tuscaloosa area, extending all the way down through southeastern Louisiana. Those are those prefrontal confluence bands that we talk about. And boy, look at that. The 3 kilometer NAM, 12Z 3 kilometer NAM coming in hot, showing the potential of even early afternoon convection there to the north. Let's see what kind of dew points we have. And look at that, right on the northern edge of those upper 60s dew points. Could even be some potential for some midday and early afternoon storms up there. Those are probably going to be a bit elevated, more due to isentropic lift. But I wouldn't be surprised to see some daytime initiating supercells here across northeastern Louisiana along the northern edge of this moisture surge. Oh, the 3 kilometer NAM already by 18Z has a 40-knot low-level jet down here pumping up into those storms. So I could even see some early afternoon initiating supercells. Daytime storms certainly do seem possible here across this area, and this low-level jet is only going to increase as we go through the day. That's your 3 kilometer NAM. This is the regular NAM. It just is going to show you that low-level jet just percolating throughout the day. A little bit of a weakness there by 0Z, but then it should ramp back up as you go through the evening hours. What an interesting setup. It doesn't seem to ramp up the low-level jet as you go through the evening. It does shift a little bit off to the northeast across northern Alabama, eastern Tennessee, up into eastern Kentucky, and the threat of severe weather is going to shift off to the northeast along with that low-level jet axis. But you do have that ribbon of a low-level jet extending back to the I-20 corridor even by late evening, even 9 or 10 p.m. See how the 3 kilometer NAM evolves that low-level jet with time. Well, we can't quite look at it, but it is coming out. These models are coming out rapidly. 12Z models. 12Z models here, convective allowing models are coming out so we can see the likelihood of these storms. And these storms percolate down through central Mississippi, back along the southwestern edge, back toward the tri-state, that corner of Arkansas, Louisiana, and Mississippi. But you just get this ribbon of potentially surface-based storms as you go through the afternoon. A fire hose just pumping out these supercells, and the threat of surface-based storms will increase as you go through the afternoon. That's right along the nose of the low-level jet. That's on the nose of that moisture. Here we go. We got it even further, 20Z. Oh, look at that. Those are likely going to be tornadic storms into the afternoon, 3-4 p.m. across northern Mississippi. We're just getting into that range here of the 3-kilometer NAM, where you can kind of assess just how widespread that convection is going to be. This is looking like a Mississippi event for that severe weather. This is going to be afternoon and evening of the 29th and the overnight. Looks like it is a little bit further north as well. All right, kudos to the SPC, the Storm Prediction Center, for seeing this so many days out. I thought this was going to be one of those preceding lower-end events, but now it looks like you could have two higher-end events, one on the evening of the 29th, one on January 1st, as well on New Year's Day. But that's a little bit further out. You want to take one setup at a time here. We'll look at the 29th. And look at that convection. We got another model here at 21Z. And it does look like you still could have these supercell storms initiating all the way back towards southeastern Arkansas, northeastern Louisiana, across this corridor. And that just develops on that moisture nose, a bit of some isotropic lift. You're also going to have these prefrontal confluence lines down here. The main front is way back up toward Missouri, and that's also, but there is more, it's more connected, that low-level jet. With that southern ribbon. And look at that bubbler up there. That's also a supercell storm. And it looks like the threat of these daytime storms are just going to persist across central and northern Mississippi, possibly starting as early afternoon, even midday up there. Look at this little lead MCS type feature moving through eastern Tennessee. I think that the threat is going to arrive across northern Alabama and eastern Tennessee during the overnight hours once that moisture reaches up across northern Alabama. You start to see those mid and upper 60s dew points surging up through northern Alabama, up into eastern Tennessee. But the main moisture nose is back here. And look at that boundary that sets up as those storms develop throughout the course of the day. And you can also see the hint in this moisture field at a dominant prefrontal confluence line, southeastern Mississippi, up toward the I-20 corridor in western Alabama. And I think that's also going to be an initiator of those isolated storms. Southeastern Louisiana, southeastern Mississippi, all the way up. You can certainly see them in the moisture field. And also the nose of this moisture pumping up toward that tri-state area, the intersection of Arkansas, Louisiana, Mississippi. That's going to be an initiator of storms. And I think that the 3-kilometer NAM, and especially the HRRR, is going to do a good job at depicting just how well this prefrontal confluence band convects from southeastern Louisiana through southeastern Mississippi up into western Alabama. And you can see these isolated storms continuing through northeastern Mississippi and northern Alabama. This confluence line here doesn't really convect as much in the 3-kilometer NAM, but it does hint at some bubblers there along the I-20 corridor into Mississippi up into western Alabama. We'll just have to keep an eye on that. And if these models trend during the day today through tomorrow toward an uptick, a greater coverage of severe weather across the Mid-South, then I think we're going to be welcomed with an enhanced risk for this area by the Storm Prediction Center. But these setups are pretty convincing. They don't favor a surging front or a squall line, but they do favor the development of these renegade supercells, just isolated supercells within these bands across this environment. So definitely an event to keep an eye out. And then we have that event on January 1st, that bigger trough ejection that also comes out. But it's this 40-knot low-level jet, lifts off to the northeast with time that we need to watch on December 29. The NAM model is definitely trending up with this setup. Seems to be agreeing with that European. The GFS has come on over with that stronger wave as well. And that's why we have dropped our purple target area there. And I should expand that further north. Honestly, that should be across central and northern Mississippi, northern Alabama, and expand that even further north into eastern Tennessee as these 12Z models are coming out with even a larger warm sector on December 29. But January 1st is going to be a big tandem trough ejection as well. That's going to be digging that closed upper level low off of Baja, raking it over the warm sector. So it looks like we've got 2 tornado events. Both have tornado outbreak potential the evening of the 29th, and then again January 1st into January 2nd with that stronger system. So I'm going to be activating storm chase mode for both of these events. Stay tuned, everybody. Certainly, we'll be activating storm chase mode for these 2 events as our very active winter 2021 into 2022 continues, and a lot of this is being fueled by that cold PDO horseshoe in the northeastern Pacific, indirectly related to the year 2 La Nina, just pumping those cold anomalies along the eastern and northeastern periphery of that Pacific Ocean. That's leading to this western U.S. trough ridge pattern as you go from west to east across the United States. A very consolidated, powerful polar front jet stream, one that doesn't have a lot of Arctic blasts that are clearing out that Gulf of Mexico, but this record-breaking warmth, which is tied to that subtropical ridge off the southeastern U.S. down toward the Caribbean, that southerly flow is just maintaining that reservoir of moisture over the Gulf of Mexico, basically serving as that rocket fuel for these tornado outbreaks. So thank you, everybody, for tuning in to this weather report. I'm going to keep you updated on the threat of tornado outbreaks on December 29 and January 1st. Never stop chasing.